constant symbol actually. Simply it is about that harmful to us. Why it is actually harmful, why they are given that symbol, we can discuss here. That is simply about the dissolving process of acid, right? So always acid must be added to the water with constant stirring, because here the process of dissolving an acid in water is an exothermic process that releasing of heat energy. Sometimes maybe it breaks the container glass, right? So that is the reason to give a caution, right? So here if it spills on your skin or on your body, what happens? It corrodes the skin, burns your skin, right? So that is the symbol here indicating you dropping of acid on the body, right? Corroding. See here, skin damage. Then here metals also affected by this, because here in activity 3 lab activity we discussed about the acid reaction and base reaction with the metal. So it can form the salt and liberate the gas. So metal strength will be decreases, corrosion, right? So that is the reason here in a triangle we have seen that symbol like this. So it is affecting the body, human body or the metal surface, right? So this is warning symbol. Then we are moving to the another topic here, that is activity 10. So what is actually activity 10? How many are joined? So many are there, right? 2-3 members need to join. Right. So here activity 10 is about to decide the strength. Sir, why you are deciding the strength? In activity 7 we have seen what ions produced in the presence of water. Ions produced in the presence of water. So here acids and bases both are producing the ions. What the ions produced by, what type of ions produced by acids? According to Arrhenius theory, acids produce H plus ions in the presence of water, but that cannot be isolated. That means they cannot be exist as bare ions. They can immediately combine with the water and gives you H3O plus ions. So which can produce H plus ions? According to Arrhenius, they are classified into acids. Bases, they can produce OH minus ions in the presence of water. So Arrhenius says which can produce H plus or H3O plus ions in the water, they are classified as acids. Which they can produce OH minus ions, they are classified here bases. Okay, we know acids are producing H plus ions and bases produce OH minus ions. Any acid or any base, can they produce same number of ions? Can anybody answer? They can produce same number of ions? No, they cannot produce same number of ions. So how do we realize that? For that, here we are discussing that in the activity 10. So that the number of ions helps us to decide the strength of acid or the base, right? So strength will be decided by the number of ions here. How do we decide the strength? By the number of ions produced by the acid or the base in the water. So here simply in this activity we required few materials. What they are here? Simply acid. What acid? Specific acid here it is taken, that is hydrochloric acid, acetic acid. only two acids I am taking, right? One we can classify as a strong acid and the other will be decided as weak acid. Then two basic substances I am considering, that is sodium hydroxide and ammonium hydroxide. Next here, electrodes are required for observing that ions using the bulb, intensity of the bulb. Then here bulb is required. Next here, connecting wires to make a circuit. Then source is required. Finally, one more you required. They are here beakers. I need here beakers. Okay. So these are the minimum required materials. Then here, how to conduct this activity? How to conduct this activity? So let us go for the activity here. Simply in the procedure, we can see the arrangement of operators, right? And adding the solution, observing. So note down the observations immediately. Because here I have four types of solutions. What they are here? Hydrochloric acid, acetic acid, sodium hydroxide, ammonium hydroxide. Four types of solution: hydrochloric acid, acetic acid, sodium hydroxide, ammonium hydroxide. So using them, I am conducting this activity. So I need to observe in each case that bulbs, right? So here simply I'm going for the procedure. I'm going for the procedure. What is that? Simply here conducting the activity using the materials, right? So I'm taking the beaker here. Beaker is taken. Then fix the electrodes in the beaker. Two electrodes are taken, graphite electrodes. Then next connecting them with the help of wires. Finally, give it to the another electrode. One electrode to another electrode using AC plug and a bulb. Then what to do? Here you need to add a solution. So first of all, I am adding here HCl solution. So these are the electrodes, graphite electrodes. They are here adding the acid in it. So which acid is taken firstly? That is here HCl, hydrochloric acid is taken. So this hydrochloric acid filled into the beaker, then switch on. What do you observe? Here bulb is glowing, right? So here observe the bulb intensity here. Mainly you need to observe intensity, right? So here just focus on the brightness of the bulb. Intensity means here brightness of the bulb, how brightly that bulb is glowing. Observe it. Then change the acid in the beaker. So take another beaker, right? So it is better to take four beakers and make four circuits using the electrodes separately, right? So in each beaker you have to fill solutions. So first beaker is filled by HCl. Then the next beaker also prepared same as the first, but I am changing the acid here. Which acid I am filling? In this I am filling what? That is acetic acid. So among these two, you need to observe the difference in the brightness of the bulb. So switch on, right? By filling the acetic acid in the second beaker. So first beaker filled by HCl, right? Second beaker filled by acetic acid. Then already we observing the bulb brightness in the first case. Then switch on the second one. See the brightness of the bulb. What do you observe here? Brightness is same. Brightness is same in the both, or giving you different brightness. Brightness is same or different brightness you are observing here. Brightness is different. So in the first one, in HCl solution, brightness of the bulb is more comparing the brightness of the bulb in case of acetic acid. So that difference here I observed, right? In the intensity, that means brightness of the bulb here. Then let us go for another. So here I'm going to write the observations here, right? What I observed, bulb glows brightly in a HCl solution, right? Intensity of bulb is low in acetic acid, right? So that I made observation. Then I am changing the solutions here. In the first one, in previous case, I added HCl solution. Now I am connecting that same circuit using the bulb, AC plug, beaker, electrodes, right, etc. things. So our circuit is designed. Then I am filling this beaker with basic solution, that is here NaOH. So NaOH is filled in this. Then switch on. What happened? Bulb glowing. Okay. Then focus on the brightness of the bulb. Then take another beaker. Take another beaker. Then arrange your circuit, taking the electrodes, connect the bulb to the AC plug. Next, here simply fill the beaker by using here what solution? Ammonium hydroxide solution. So ammonium hydroxide solution is filled. So ammonium hydroxide filling into the beaker, then immediately go for the switch on. So if you switch on, you can see the brightness of the bulb. So compare these brightness of the bulbs. Brightness of the bulbs. So here brightness of the bulb is observed in NaOH solution is much comparing with the ammonium hydroxide solution in the second beaker. This is the difference we are observing. So here simply we can write here observations, right? So here what the observations are here? Observations I made here simply bulb brightly glowing in HCl solution and NaOH solution when we compare with another acid and another base. So intensity of bulb is low in acetic acid, and also I observed intensity of the bulb is low in ammonium hydroxide. So bulb brightly glowing in HCl solution and in NaOH solution, that intensity of the bulb is low in acetic acid and ammonium hydroxide. What could be the reason here? Can anybody expect the reason for this glowing of a bulb with different brightness in a different acids, also in different bases? Can you predict? Anyone?
Sir, because of ions.
So, according to electrical conductivity of liquids in 8th class, we learned that energy flows through the liquids because of presence of ions, right? So ions are much in the liquid, that what here supplying of energy through them is more. So much energy is flowing due to more number of presence of ions, more number of ions present in the liquid. So here what we can write the result here, intensity of bulb depends on the number of ions in the solution, right? So intensity of the bulb depending on the number of ions in the solution. So based on that, here more ions present in a HCl solution, right? Right? And NaOH solution. Okay. So comparing this HCl with CH3COOH, present in HCl is more. Simply, there's something confusion in typing. HCl is more than CH3COOH, and NaOH is more than NH4OH respectively, right? So here simply HCl and NaOH are producing more number of ions comparing with CH3COOH and NH4OH respectively. So HCl with CH3COOH comparison and NaOH with NH4OH. So NaOH, HCl producing more number of ions. That is the reason here to conclude which can produce more ions in aqueous solution. They are called as here stronger acids or stronger bases. So HCl acidic in nature. That's why HCl is called as or known as stronger acid comparing with CH3COOH. NaOH is called as stronger acid comparing with NH4OH, ammonium hydroxide. So, which are stronger here among the four solutions? Can anybody? Which are stronger? Maybe in acidic nature or maybe in basic nature? Among the four solutions. Answer me. HCl, CH3COH, NaOH, and NH4OH. Four solutions are given. How I decided which is stronger, which is weak? Here, based on the brightness of the bulb. Brightness of the bulb increases with increase in number of ions produced by them. Using the number of ions present in the solution, we are deciding the strength of the acid or the base. So, stronger, here acid is HCl and the base is NaOH. Weak, acid is CH3COH and the base is NH4OH. Right? So how I decided? Because here HCl producing more number of ions in the liquid water and base is producing more number of ions in the water. Comparing with CH3COH or comparing with NH4OH respectively. So stronger acid is HCl, stronger base is NaOH, weak acid is CH3COOH, and weak base is ammonium hydroxide. So this is activity number 10. Is it okay? Or left any confusion? How to decide? Are there any confusion? To decide which is stronger, which is weak, right? So no confusion. My suggestion is while you are preparing, prepare activity 7 and activity 10 together because process is same. Only observation points are different. In activity 7, just you are observing bulb glowing or not, right? Observation here, bulb glowing or not, right? Then in activity 10, we are observing brightness of the bulb. This is the difference. Then just few materials are taking here different that you have to differentiate in the two activities. Only in the required materials, only in the observation points. So nothing is difference between activity 7 and activity 10. So prepare them together, just differentiate them in the following points. What they are required materials and brightness, observation points. Okay. So there you are observing only the bulb is glowing or not and ions are present or not. In the activity 10, number of ions present in which solution, why you are saying that? Because of the brightness, right? So this is the difference in the preparation. Activity 10 and activity 7. Clear about? Are you clear about activity 7 and activity 10? So we compared how to prepare them. Both are similar in process, but only the required materials few added or deleted and then observations, right? So let us move to the another here, right? So no animation given for that. Okay, up to that time we will cover that. Right. Just covered. Then what is your activity level? Before that, one more interesting topic is introduced here. That is here pH scale. What is pH scale? What is pH scale actually? Who introduced that? Right. So pH scale is introduced by Sorensen, also called as universal indicator. It is also called as universal indicator. So why we require pH scales? Suppose if I want to know which is stronger acid, which is stronger base, which is weak acid, which is weak base, or I want to know the particular substance strength. Is it possible to decide directly without conducting the activity 10? Can anybody? I want to know the strength of the acid or the base, whatever it may be. I want to know the strength. Shall we decide the strength or something concentration of the ions in the liquid solution, aqueous solution, without activity 10? Is it possible? Not possible. Okay. Suppose if you are conducting, did you compare that strength with other? Can you assign a value for that? No possibility. No possibility. Just we are blindly observing the brightness of the bulb, but you are unable to know the information by saying the brightness. This much, this much, this much. No comparison. Just it is a blind comparison one to the other, only depending on the brightness of the bulb. No given any value by that. So here that value we are assigning for the substance based on the concentration of ion here. So that is only here ions concentration given as a measurement. So that we are calling as here scale, that which measures the concentration of ions. What ions, sir? Especially hydrogen concentration ions. Only hydrogen concentration ions. Sir, according to you, only H plus ions are produced in the acid, sir. How you calculate that H plus ions concentration in the base? Right? So here the simple solution, anything, it may be acid or maybe the base or maybe the neutral, that behavior found in the presence of water, that we confirmed in the activity 8. Already we did it. Ions produced by the HCl gas only in the presence of water, not in its solid form or in the gaseous form. We cannot find that nature. So liquid solution is required. So liquid solution we are preparing using the dilution. That means dissolving that salt in the water, right? So here you are preparing the aqueous solution. Only in the presence of water they are able to produce the ions. So actually water also splits into positive and negative ions as H plus and OH minus ions. When you dissolve neutral or the base also, you can find that number of ions of hydrogen. So comparing with the acidic solution, that neutral and basic solutions consist less number of hydrogen ions. So that is the reason to depend only on the hydrogen ions concentration. We have one more scale also, which calculate the OH minus ions concentration. That is called as pK scale, right? pK scale, that is given in the 12th lesson, right? That information given in the 12th lesson, not in this lesson. So using the pK scale, you are able to decide that strength of the base, OH minus ions concentration, we are discussing using that scale. So I will try to give that page number. Just a second. How to find that? Maybe it is in 283, 284, like that. Find that in the 12th lesson, especially near the topic soap, right? Soaps are given. That topic will give you about that scale. Okay, I am unable to find that. Let me check. Okay, I am unable to find out. So one more is there, that is pKa scale, right? So it will calculate OH minus ions concentration. So here pH scale are also called as universal indicator. So why it is called as universal indicator? It is only the scale which can give you three different natures. What they are here, acid, base, and the neutral. And also it will calculate ions concentration to decide the strength. So many things, that means much information only by using one paper, which is available in yellow color, which is available in yellow color. So pH paper color is yellow color, right? So he is the person who introduced the pH scale, Sorensen, right? So scientist, chemist introduced pH scale, right? Which can calculate H plus ions concentration. So Sorensen introduced that pH scale in the year 1909, that in terms of pH and pOH, right? pH and pOH. So OH ions concentration, H plus ions concentration, that both will be calculated by using the pH scale. Then here it is simply named as pH, right? In that, P stands for particular word called potential, right? It is called potential. So here, what is the meaning of potential? Which language it is? So that language is German language, potential, pH. In that pH, P stands for the potential according to German language. So potential meaning is, right? Potential meaning is power or concentration. What the meaning of potential? It is means that power or concentration. So you are able to know the power of the acid. Its strength. Power means its strength. So that strength you are able to know. It may be acidic strength or basic strength or maybe the neutral. So any strength you are able to calculate by using a simple scale called pH scale. So need not to conduct any activity using simple one yellow color paper like your litmus paper. Just dip that and observe. So how would I know that value? So that is the reason to given the values for the scale, right? So it consists of measurements, right? So that will give you the strength of ions present in the solution. Maybe H plus ions or that OH minus ions, right? Both you are able to calculate. Then here it is also called as potential. Hydrogen potential will be calculated by using the pH scale, right? Then here uses of pH scale. What are the uses are there with the pH scale? Look at them here. So uses of pH scale there in our stomach, that means digestive system, rainwater, in our mouth, tooth especially, right? Teeth are very important organ in our mouth, that which can chew the food, right? Cutting of the food, right? Grinding. So here simply 20 to 50% is, it depends on the person chewing, how they are chewing. So based on that, some of the food digested, easy made process for digestion. Then pH of the land pH also important in medicines, curing many diseases. Nature of a solution, these are all found using simple pH scale. So these are the applications of pH, right? That applications also we'll discuss in this topic, right? So just have a screenshot if it is possible. Is it allowing or not? I don't know. Or you can note down on the notebook later on by watching this video again. Is it allowing you to take screenshot? Yes, take it. So simply this information you required about pH scale, right? Then look at here. I'll give you about pH, right? So let us see pH scale here. pH scale consists values from 0 to 14. Values from 0 to 14 here. See here that I am showing you here simply 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 values. So see here, for each and every value, we are observing the different colors here. We are observing the different colors. Why they are given different colors here? Why they are given different values here? So actually the original color of the pH paper is yellow color. What is the color of pH paper? Yellow color. So here you are observing the different colors for the same pH paper, right? In a your what are simply observations, in your observations, what you are, where or when you are observing, when the pH paper introduced into the different liquids. So when you dip that into a particular solution, take it out and observe the color of the pH paper. Is it changed or remains for the same color? If it remains, no, it won't remains actually. pH paper is made by using the different chemicals. So it can convert into different colors. It won't remains in its own color by dipping that into any solution, right? So based on the strength, that means concentration of ions in the liquid solution, it will convert into different changes into different colors as you see on the screen. So here simply that changes. Suppose I am indicating a particular value here. If it stands or that pH yellow paper turns into green color, it is assigned with the value 7, and the color you can observe there green color. So on the actually on the yellow color paper you didn't see any color. Suppose I will show you here yellow color paper, right? Here that yellow paper like this. This is original pH paper which you find, right? So this is the color of the yellow paper. So here, did you see any color 0 to 14 similar to this pH paper? No. This yellow also different in the third, light or very bright. Something difference is there, right? So like this, you can find the colors here, changes. Suppose this yellow paper changed to here green. What the value you can assign? 7. Suppose this yellow paper changed to violet or dark black, dark violet or black. So that value you can assign here 40. Sometimes that may give you purple color or maybe it give you dark black color. So dark purple or black color will be assigned with a value 40. So like this we can find out. So pH scale consists of values 0 to 14. Exactly that is giving you 7, suppose green color. Then you can decide the nature as here neutral. Suppose here if you are taken base, what you can find here, that base pH values are greater than 7, above 7. So that values are here 7 to 14, any, but not equal to 7, not less than to 7. It is greater than to 7, 7 to 14. That value lie between 7 to 14. Okay, suppose if you observe that value 0 to 7 between, that you can decide the value 7 to 14 between acidic nature. So less than 7, exactly equal to 7, what we decide? Neutral. Suppose it is 7 to 14, it is decided as basic. Alkaline. Alkaline means the base which dissolves in water. Alkaline meaning is what? The base which dissolves in water called as alkaline. Then here neutral substance 7. See, I used the different colors for indicating neutral substance, acid substance, basic substance. Neutral green in color, that's why I used neutral green color. Acids red in color, red value, right? Bases blue color or that purple color, right? So different values are assigned here for different scales. Then here using this pH paper you are able to find out the different substances values here, right? Different substances values here. Look at that values I'm given here by using the animation, different colors here. Let's move here. Okay, see them. Lemon is given, orange is given, banana, milk, acid rain, right? Pure water, milk, egg, baking soda, milk of magnesia, ammonia, bleaching powder, right? So bleach. The next soapy water, liquid or a drain, cleaners, right? So that means what Domex is something we are using for bathroom cleaning, Harpic, like that. So drain cleaners. So different substances here collected with the different colors of litmus paper. So you can find it. So here you can find the HCl solution color with this litmus paper I said, right? With the litmus paper I said. Okay. Then if you use stronger base NaOH, what the color you can find? Black color. So using that colors, you are able to decide. You are able to decide what strength of that particular solution, pH solution color, pH paper color will be assigned with a value particularly. So this you need to have an idea. What they are here? These 0 to 1. So actually 0 less than 1 is impossible. 1 is possible. So that 1 is given by red color, dark red color, right? So here these are the values. Are you clear about this pH? Are you clear about this pH? Have you seen that pH colors? Right, thank you. Join immediately with the same link, right? So this time completed.